Hi,
Howdy.
how are you?
I am improving
Okay.
in my list. I'm less laden by a list of things between the number of things between me and summer vacation is dwindling by the day, and I'm very happy about that.
That's great.
Yes, it is.
Hussain and Morgan. Hi. So I don't know who's going to be here. I had a couple people say they couldn't make it today. So um, I don't know if people have any updates they want to start with.
I mean, I'm happy to talk about my work with the breast cancer computer tomography project.
Yeah.
Okay. So yeah, Dick and I have been talking a lot about getting the figures, getting the writing together for the chapters for the textbook he's writing. There's a lot of work, quite a bit. We work some pretty weird hours too, because I take breaks during the day, and sometimes I work pretty late, like from midnight to 1 or 2 in the morning. But I'm happy to. Oh, excuse me. I'm happy to share some of the figures and some of the conversations we've been having through email, because they've been pretty productive and constructive. Because you can obviously like messaging back and forth, getting the designs together. We're working with some scientists. I believe one is in like Argentina, I think.
Okay.
Marcelo, the orthogonal system. This is what's known as you guys can see this, right? It's pretty cool.
Yeah. Well, I haven't seen it. No.
Yeah. This is the design for what the orthogonal system is going to look like. Essentially, this is how we are going to compress the breast tissue in a way that's much more easier and manageable on everyone involved, much more efficient and much more effective in being able to screen and detect it. Look at that. That's so cool. They're able to
Yeah.
just design this I think they use like computer-aided design. Computer-aided design, excuse me, yeah. So CAD's like, because I'm not an engineer, so I'm not so familiar with this. But this is basically the process of how you actually design the hardware for being used in these sorts of things too. So it's pretty cool. And like, my bachelor's was in physics, not engineering, so I would learn about the maths and the science behind this sort of stuff, but not actually like building or using the tools and materials so much too. So this is really, really cool. Yeah, like and hopefully it doesn't look too intimidating. Yeah, so on top of that, Dick and I have been getting figures together for the textbook chapters. So we're trying to visualize interaction patterns between spheres as they reflect and as they absorb, and trying to get the best figures and diagrams together to illustrate what a sphere really looks like. Seeing how it can demonstrate X-ray reflection, a particular Bragg angle. So the Bragg angle would be the angle between incoming and reflected. I think that's exactly what it is. So like so like yeah, yeah. Okay, excuse me. No, the Bragg angle would be so when the X-ray beam and the lattice planes are spaced, you have a particular integer that can be used to detect how the reflected and like the incoming the reflected angles differ between one another. So essentially, I'm sorting out the maths and physics to get that together from a software and scientific point of view. But I'm really excited, really, really, really excited with how these things are turning out. I think it's really, really cool. So, and these images they've sent, that's so like this is what we've been looking for. So yeah, yeah.
Yeah.
Okay.
That's great. That looks good.
I asked Dolly to make an image of a Jonosphere.
Oh yeah.
It kept because I've told you guys before, the Jonosphere is a sphere with two different sides.
Right.
So they have different properties, different materials. So you could have like one that's hydrophobic and one that's hydrophilic. In our case, we have one that's reflective versus one that's one hemisphere that's reflective versus one that's absorptive. So this is what I got.
Oh, there we go.
This is not what it should look like. This is not what it's
Yeah, I
like.
know. It's
No, ChatGPT. One should be reflective, the other should be absorptive, and yeah.
I like how it puts together text. Like it's a sort of almost right, but it's not. Targeted X-rated math steering.
Yep.
Yeah. But yeah, that's great.
Yeah, really happy with how this stuff is going. And other news, I think I might have mentioned this, but with Alter Learning, they're moving me up to AI team lead. Yep.
Good.
Yeah. Really, really, really exciting. I'm going to be leading the group of data scientists, machine learning engineers software engineers, everybody. I'm guiding the direction of the project and how we use AI in our systems. So it's going to be a lot of management and leadership work. So it's really, really, really exciting. Yeah.
Oh, good. Yeah, that's great. Well, congratulations.
Thanks. Okay.
Okay.
Cool.
All right. Thanks. Jesse or Morgan?
I mean, most of my updates are just I'm almost done with finals, so that's basically it. There's some things that I might more so share tomorrow than today.
Yeah.
I guess I don't think anyone from the Google Summer Code will be here today as well, but my updates are a little bit more for other things in other spaces. I may have a slight professional development related discussion today, but mostly the background work for Joe Pro, the background work for sort of the mental health working group. There's been a lot of really interesting discussions there, and maybe the most tenable thing right now to say is I am one of the courses that I was taking covered parts of natural language processing, and they also had the end of their course had to do with ethics around NLP, and I was, bias in NLP is a important and a fairly centered area, but it was interesting because the final project for the course was centered on ethics specifically, which is cool because it's as a side note, it's really interesting in this program to see how much emphasis and in what ways there are in communicating what you're doing, because it's kind of this, some things are much more conversational, some things like just do the problem sets, some things are do a presentation, present your ideas, write a report. And it's been quite varied across the different courses and sort of the emphasis on which part, which makes sense because some of them are, taught by like a computer science person. Some of them are taught more interdisciplinary focus. But in this course, the only thing we did at a presentational or like kind of conversing our ideas level was this presentation. So it was a little bit, it was very interesting in the sense of there was this sort of gap between, okay, we're going to talk a little bit about ethics in the course, but I'm familiar with papers, but I'm not familiar with, I'm not that familiar with natural language processing in general. And the final presentation was basically us sort of reviewing an article or a journal, like an accepted journal paper, NLP centered venue kind of a deal. And it was very interesting because I think I might go over the paper a little bit more in another meeting. But one of the things that I really appreciated in this space was there's a much more overt emphasis, or at least in certain. There was an interesting mirror in the coursework and in the paper about this emphasis on a lot of, how to evaluate certain models, and then evaluating these models that are allegedly built for a specific domain group, like in the case of psychology or like gender bias is a very common bias to look at, and it's sort of, especially because of how language is made with like this sort of masculine and feminine both words, but also associations. There's a lot of things encoded in that makes it kind of easy to do. But in this case, the paper I looked at ended up tried to be intersectionally focused by, okay, let's bridge from this more formalized, slightly more mature area of gender bias in words and text, like word association, to mental health, and like mental health associations. Like, is someone depressed, and is that like more likely to be associated with a woman or a man, and why or why not? Are they receiving help? Are they avoiding help? Are they did this person make me angry because they were this this insert mental illness affected person made me angry to deal with them, and was that more likely to be a woman or a man or a male or female? And it was interesting to kind of see how this, from an interdisciplinary point of view, it's been interesting to see how a computationally based thing like NLP is sort of like, what's their stance? Like, I actually want to get more into what is there like a specific approach that's recommended, or is this like you should talk to the social sciences, you should talk to these domain groups. How do you talk to the domain groups to kind of find out what to do? I think that's my very superficial take on it, is that it's still quite like there isn't exactly like a formal framework for doing it, but there's at least an acknowledgement that, hey, we need to refine these models based off of the people doing the work, or in that space, have better dialogue between sort of the, okay, we have this database, or we have this model trained on data from this group, but is it actually reflective in a way that accounts for bias and accounts for what is the actual more raw experience of that domain, or the stakeholders within that domain? So it's been an interesting process of getting like kind of very preliminary experience in doing that. But now, like, it really made me think of some of the premises of SET, as in society ethics tech group, and getting like it was an interesting, it's sort of the first time from a more computer science, data science approach that I've seen like overtures towards, it's important to have everybody in the room and here's one way to do it, kind of a thing, almost like methodologically. So that was cool. That's something that was a cool thing to explore. And I'll go into some more details about that, or maybe talk about the paper tomorrow. But I think general takeaways from that are just how interesting the space is between like people doing the work in a specific, like, I think most people know this here, but like my general viewpoint is like, the relative maturity of a field, like, I think cognitive science is a great example of this attempt to unify and mature certain fields of study that are pretty disparate under the lens of, okay, a computational guy is, and we can debate whether or not that was successful or not, and to what degree it was successful with like this sort of computational approach to whatever computational cognitive science, or computational cognitive science and its influence on psychology or psychiatry, or even things like, and this is a little bit more interesting relative to the mental health working group that I'm trying to put together, but like social work, or the various things that contribute to both mental health in terms of the diagnoses, the practice, the actual, the theory, the practice, and sort of the on the ground work in that space. So I'll conclude this by saying I'm two of the most interesting things for me lately, from kind of stemming from the degree, have been looking for more applications for this. Like I had no particular sense of, okay, I really want to do NLP stuff coming into the degree, and now I'm a lot more curious about useful applications and the ways I can use it to achieve some of my other like broader goals. So it's cool to see that happening, and then also the tie between that and the actual data ethics course that I took. So it's interesting to see some more work in those spaces happen. So that's sort of my general update, and then I might have I probably will leave it at that and maybe say something about more like professional development related things tomorrow, because there's a very specific part of dealing with the prototyping process that I'm getting a lot of experience in, and understanding the connection between making a decision at a higher level or a group administrative level versus having prototypers make something to that vision. So I look like that can be a whole discussion to talk about that I feel like we all have a lot of different kinds of experience in, particularly in this group. So yeah.
Well, that's great. Thank you. Let's see. Okay. So yeah, well, Morgan, did you want to give an update?
Well, not too much of an update. I mean, just trying to think about this meeting's goals, and I mean, there's some really interesting things going on, just in various topics, and I would just ask Jess if he saw that PNAS paper I put in data SciML, that large language models, deception in large language models. I noticed that Terry Sinowski was the reviewer or editor. I forget how PNAS works.
Was it like the one
the difference
recently?
between those two? Yeah, it's the one recently where they've come full circle on the LLMs playing diplomacy.
Oh, I see it. I see it now.
Yeah. And do you remember the diplomacy, paper from like how long ago was that now? I'm not going to remember the time on it, but anyway,
Yeah.
It's yeah.
Yeah, we did
nice
talk about it last year.
Bring to fore the kind of all the theory of mind problems that you have with LLMs, or the end the discussion of them. But might be interesting, and yeah. But I was wondering, in terms of the spirit of this meeting, if you wanted to say more broadly about the Diva Worm projects. Hussain had posted a AI and kind of bioimage analysis.
Yeah, I can talk more about that one too. Yeah.
Recently, yeah, and I had posted the Loke Royer, Chan Zuckerberg, has kind of formalized that ChatGPT work, or like they have that Omega pipeline.
I'd be happy to with Devil Worm, because which, by the way, I've been getting on board with some contributions with some stuff there. So I'm really happy to be on board with Devo and Worm, so that's cool too. Yeah.
So, and Bradley had said like it would be good for us to talk more about kind of the work in Diva Worm since 2017.
Yeah.
I was wondering if there were any particular, like, we're kind of doing this right now with the NerdTechX GitHub. Like, are there any particular projects, or like do you think that there's some kind of larger kind of themes in Diva Worm in terms of, like, say, bioimage analysis that would be good to kind of collect together and talk about it at a kind of more meta level?
Yeah, so let me pull something up here in the chat. I'm gonna give an overview of something here. So let me go to let me share my screen first of all. So Morgan asked about different things in DevoWorm, and of course, just recently we had the 10th anniversary of DevoWorm, so that was supposed to be in April of 2024 because we started in April 2014, and we've gone for about 10 years. People have come and gone, but we've been pursuing a number of projects within that time. So I actually have prepared some things for the sort of general consumption on these things. So one of them is this YouTube video, 10 years of the DevoWorm group. So it's about 90 minutes long. So it's really long, but it does go over a lot of the history, a lot of the different projects. I've put it into a project timeline, a lot of the different initiatives that we've kind of worked on over that time, kind of getting into it as a deep dive, and then also some how we interface with OpenWorm. So I talk a little bit about the robotics work that they're doing in OpenWorm and other types of things. So this is if you want to know kind of the things we've been doing since 2017. This video kind of covers that 7-year period. So you can go and look through that video and just see if there's anything of interest. I didn't, capture everything that's been done in that time, but it's I think it kind of gives a good overview of a lot of the things that were done because it's been really kind of hard to remember everything. So we were doing things back in like 2015, 2016, and I don't remember those things necessarily. Some of them kind of, like for example, we at one time wanted to do work with CompuCell 3D, and then we kind of didn't do anything with it anymore. And it's just largely a function of who picks it up, who contributes, if it's useful to them, if it fits within what we're doing at the time, and so forth. So, we got in a situation where we didn't do anything with it. Yeah, Hussain knows who James Glazier is in the CompuCell 3D group. And so, of course,
I don't know if he made it. He was like one of the people in charge of it.
Yeah, he's one of the main people.
And by that, Bradley, do you mean that was actually like a GSoC project?
We didn't really. Yeah, it wasn't.
Was that?
I don't think it was a selected GSoC project, but we did do some things with it. Sort of, if it had been something we had pursued through GSoC formally, because I don't think it was selected at that year, but we probably would have had more incentive to continue on. But yeah, so I mean, I would like to pick that up again, but I think that talk that I showed, that gives a pretty good overview of all the different themes. So, just working on like in one software package is great, getting something up and running, but, fitting it into some of the larger research themes. Like, if we were to build like a CompuCell 3D model, what would it be? It could be anything, I guess, but what would it be? And yeah, because, and, it really depends on the type of data we have because, I guess you do need to calibrate the model with data. And that makes it a more powerful model. And, but also, tying it into some of the theoretical questions because that's been sort of the hallmark of the group is having that tie-in. But in any case, yeah, look over that video, get a sense of some of the themes and projects. And then there is a second one where, of course we have DevoLearn, which is the software sort of initiative that we have where we're doing things with image segmentation, we're doing things with deep learning, we're doing things with graph neural networks. And so I prepared another YouTube talk for general consumption. This was late last year. This is on DevoLearn, the 10,000 meter view. So just an overview of the origins of DevoLearn are sort of what we're trying to do now, our repositories, and then what we want to do in the future. So that's another place, to get a sense of like that set of initiatives, how that's being shaped, and that kind of fits. That's a subset of DevoWorm activities, but I just give you an idea of like two of the things that we're doing that are sort of where we have a really strong vision for things in the future.
For sure. So, do you think there's? Could you say a bit more about the data, then, in terms of just what big repositories are we looking at? Sorry.
Oh, well, we have the various data sets that we have. I've created a repository of data sets that we've analyzed. There's a lot of secondary data out there on C. elegans in terms of developmental cell location, developmental cell properties, attributes. The C. elegans community has a great number of resources on like genomic data and other types of data. It's a matter of having the sort of the right place, finding the data, of course, and then processing the data. So the data is archived for a number of things in the C. elegans community, and then we've taken it and processed it for our own needs. So a lot of that is, in the form of CSV files, and we have a repository for that. I'm not going to bring it up right now, but it's basically GitHub Divoworm or something like that. So, but yeah, we have data sets like that are processed for what we've been doing. We have not only in C. elegans, but in like zebrafish and organisms like that. There's the systems biology database, which has a lot of like microscopy data sets and cell tracking data sets. And then the C. elegans community has data that, for the community. And of course, OpenWorm, one of the initiatives of OpenWorm has been to create open source data sets. So like labs will generate data, but they don't have like the means or the incentive to make that open and make that shareable. And then that's something that OpenWorm does. That's been something that Porrig has been leading up. So Porrig Gleason. So yeah, there's a lot going on, and Hussain had to go. Thank you, Hussain, for attending. And so that, all right.
Sure. Yeah, it does still seem like there's some larger repositories for non C. elegans. And I'm just like what efforts or maybe gotcha.
Yeah.
Well, I'm still looking for more developmental, tissue differentiation.
Yeah.
Data resources.
Yeah, it varies. Now, like we've been able to get a lot of data out of papers. So if you go to a paper, some of them will have repositories. I just ran across a paper I'm going to talk about on Monday's meeting, where they have gene expression data in cells and in larvae of C. elegans. So, this is something we can extract and use pretty easily. Because a lot of the papers, especially the genomics papers, they'll be in a very difficult to use format. They'll either have like an atlas where you can look things up and there's no back end where you can get the data. So they don't have, they set it up so that the database is sort of, not accessible. And there's no API. You can visualize things on the front end. Or, it's like the files are huge and they're not accessible to people. And even if you did access it and say like a table, you couldn't understand it. So that's one of the challenges we have. And so we just need to find those data sets and follow through and doing something interesting with them. So.
Yeah. I was wondering how much that Sam Gershon comment, I felt it was kind of pointed towards neuroimaging, but it's like, have you seen other areas?
Yeah, the Sam Gershwin comment on X, I guess, where he
about like, everybody doesn't manage their data very well, that kind of thing.
Yeah. Yeah, it's very challenging to because there's no incentive necessarily for labs or groups to like make their data public. I mean, they can dump the data out online, but that's not helpful always. And so as being a connoisseur of those type of data, I've seen like a lot of different ways that people have sort of made that public, from like online tables that are not formatted well to like things that don't have a back end accessible to people to actually tables that are useful, and like it's just really, yeah. So one of the things we've done to some extent in DevoWorm is to, get some of those data and pull them together and do analyses on them. But you have to know kind of what the variables are, what they mean, and that's the challenge. So we can talk more specifically about data for something. Yeah.
Yeah, it's interesting. I mean, it's a very similar. I mean, it's not just the raw data, but it's also the analysis that people are publishing too, which would actually be really, really great to have as well.
Yeah.
And I just wonder how similar that is to kind of neuroimaging, where at first, people are just going through papers and kind of, scraping tables and and kind of published results versus, again, just like, no, just have a standardized way of giving us all the actual output. The actual computational output, as well as kind of the mid steps. Sorry, we're down in LA for my daughter's graduation, so I'm multitasking here. Sorry.
Oh yeah, no problem. But yeah, I mean, I guess the big problem or barrier is that you have no real good standards for sharing. I mean, there are standards, but people don't. People have to follow them, so people often don't. But also that if you share data, what are you going to share? So like I can generate data from a machine, and it can give me very raw, unprocessed data, and it doesn't really do anything. I mean, it doesn't mean anything at that level. You have to like transform it into variables, and so sometimes people will just give you the variables without the underlying numbers. Sometimes they'll give you the raw data, and you can't interpret what those outputs of the machine are. And so, what are you going to do? How are you going to like connect the data with answering a question? So that's the thing. You have to share the data at the right level, but also, is that how much effort you have to put into doing that, and how useful is it for the end user?
Absolutely.
Yeah.
Absolutely. Yeah. I mean, yeah. As well as it should probably come with like a function locker container with the codes, with working versions of the code that you actually used, right?
Yeah. Oh yeah, I mean, people have people do various amounts of work on that. So some people have really done a good job of building like a container you can like interact with the code. Some people just kind of dump it out there because there are mandates that funding agencies have and public journals have, and so you meet the minimum requirements for that, or you put a lot of effort into sharing the data. Like in the C. elegans community, they have tools for that, so it makes the cost of doing that less, and so people tend to share their data more, and so in the sense that it's usable for other people. So yeah, there are a lot of standards, a lot of things to get through, to understand. And C. elegans people are lucky because they have a willing community for that. Well, it looks like we have Dick is here. Hello. And Hussain's back. Yeah, okay, Hussain. So yeah, you wanted to say something, or I guess. I don't know, Hussain. Did you have something you wanted to?
Yeah, no, Dick and I have been meeting to discuss moving forward the breast cancer computer tomography projects with both on the writing side, the coding side, and helping with the engineering side, getting some computer aided design together. So yeah, I just wanted to ask if Dick wanted to join. So I just sent him an email because I was already in this meeting. So yeah.
Great. And you said that you have been making contributions to OpenWorm. Did you have anything to report on that, or?
No, I don't have anything to report. Just
Okay.
right now, I made some edits to a few README files and trying to look into Docker, using the Docker and seeing how to like it's difficult. It's difficult because you want to see what issues are there, but like which issues need to be addressed more quickly. But like you know, sometimes it can be hard to tell. That's it.
Okay. Yeah, I know. It's always a challenge to know what needs to be done, and most people are really spending a lot of time on the creating issues and maintaining. And we don't. I know OpenWorm doesn't really have that right now. So, but yeah, I like the Docker container approach, but we have never. DevoWorm has never contributed to the Docker container, so we don't. I mean, we could make our own, I guess, but I don't know if it's worth it. Because like the OpenWorm Docker, if you download it, it's like you know you open it up on your machine. It's this virtual machine that will run all of the simulations.
Yeah.
And,
I think at the very least, even fixing out things with issues, with bugs in the code, stuff like that. Even just like updating requirements, whatever helps. In some ways, those will go a long ways in the long run. So those are pretty helpful. Yeah.
Okay, well, I get a Shubham is here, and we have an update from Shubham. Jesse, not anything in particular. I have been busy with my midterm exams, but next week we'll be starting with the reinforcement learning part. So yeah, Shubham is working on reinforcement learning and the open source sustainability project. So I'll be happy to see that. If you can, if you get to the point where you can share something, Shubham, that would be great by next week. And then, of course, our GSoC students were not able to make it today, so it's a busy time for people. Yeah. Okay. So, yeah, let me move on here. I wanted to get into a feature. Actually, there was an update from Sarah, and she had a couple papers that she highlighted in some of the things that she was running into in her work. So this is the first one. She's doing the stuff on LLMs and open source sustainability. So the first paper is a arXiv paper on SWE-Agent, agent computer interfaces, enable automated software engineering. So this is where you're using a language model agent, and this is where you're dealing with an integrated software or integrated development environment, integrated software development environment, and you need to do complex tasks in software engineering. So this is a nice environment because the software engineering development environment is digitized. We can do things with designing bridges or designing cities or something, but that's usually those tasks aren't all digitized. So they implement the language model on these tasks. We posit that ML agents represent a new category of end user with their own needs and abilities and will benefit from specially built interfaces to the software they use. So, Sarah is working on sort of developing large language models as these sort of FAW contributors to an open source project. And so, they would be doing things like contributing, creating issues, maintaining things. That's an interesting approach, but we have to sort of a framework for this. So we investigate how interface design affects the performance of language model agents. So one of the things they need is this sort of interface, just like humans, so that they can interact with the project in some way. It's not just enough to say, to give it a list of tasks, you need to have these issues, these issue boards and things like that, so that the project can be spatialized and there's some time depth to it, and there's a way to put things together. at the global scale. As a result of this exploration, we introduced SWE-Agent, a system that facilitates large language models or language model agents to autonomously use computers to solve software engineering tasks. So this is kind of an idea, sort of what she wants to do, but this is in a very limited context. So what they're doing here is they have this custom agent computer interface that significantly enhances an agent's ability to create and edit code files, navigate entire repositories, and execute tests on other programs. We evaluate SWE-Agent and SWE-Bench, which is, I guess, a set of benchmarks, on human eval fix, which is, I guess, a benchmark. So SWE-Bench and human eval fix, I guess, are benchmarks, achieving state-of-the-art performance on both these benchmarks with a pass rate of 12.5 and 87.7% respectively, far exceeding the previous state-of-the-art achieved with non-interactive language models. So this is, it looks like there's probably some work to be done in this area. There's this proof of concept where they put it up against benchmarks, and it did maybe good, maybe not so good, but there are different ways you can. At least you have we know of a way to do this or to implement this. The second paper is this AutoCodeRover, which is autonomous program improvement. This is also on the arXiv, and this abstract reads, researchers have made significant progress in automating the software development process. So again, they're turning to software development and, that world. Recent progress in large language models has significantly impacted the development process, where developers can use large language model-based programming assistants to achieve automated coding. So this is where software engineering involves the process of program improvement apart from coding. So you're building code, but you're also trying to improve the programs you're building. So you're trying to, do things like refactor the code, maintain the code, evaluate the code, and build new features into the code. In this paper, we propose an automated approach for solving GitHub issues. Actually, this is something that Sarah wants to focus on because it's sort of the lowest hanging fruit, is quantifying GitHub issues, solving them, seeing what the agents can do to solve them. So this is their measure of program improvement. In this approach, LLMs are combined with sophisticated code search capabilities, ultimately leading to a program modification or patch. So this is the improvement is the patch or this modification. In contrast to recent LLM agents approaches from AI researchers and practitioners, our outlook is more software engineering oriented. They use an abstract syntax tree, which is a type of program representation, as opposed to viewing a software project as a mere collection of files. So they have this hierarchy that they operate on. So it knows kind of the files that are involved in the program, and it can link those together. Our code search exploits the program structure in the form of classes and methods, which are parts of the program, to enhance the large language model's understanding of the issues root cause. So it can go back and reference different classes and methods to see where the bugs are, where the program can be improved. And then the use of spectrum-based fault localization using tests further sharpens the context as long as a test suite is available. There are experiments on the benchmarks of SWE-Bench and SWE-Bench Lite. And this consists of 300 real-life GitHub issues, and these show increasing efficacy when solving GitHub issues, 22 to 23% on SWE-Bench Lite. So on the full SWE benchmark, consisting of 2,224 GitHub issues, AutoCodeRover solved around 16% of those issues, which is higher than the efficacy of the recently reported AI software engineer, Devin, from Cognition Labs. This is an agent that's an automated software engineer. So I don't know, I'm not familiar with Devin. I guess Morgan's talked about Devin a little bit in the past, but I'm not familiar with its performance.
Copilot. Yeah.
A Copilot? Okay.
sort of.
Yeah.
Sorry, I've got a soundtrack behind us now,
Okay.
so I'm kind of keeping my mic muted.
Yeah.
Yeah, Devin is so I got invited actually to Devin's Slack channel to use prototypes of Devin. So that's the AI software engineer. You can actually use it for some basic things. Make it build stuff from scratch. Works with the infrastructure very well. Front end, back end, like full stack sort of thing. Add what you want to whatever you want to build. So Devin codes it for you. It's still in like beta, like prototype beta stages. But there's a Slack channel for it, so yeah.
Okay. Yeah, so those were shared by Sarah, and she couldn't make it today, but I think that's interesting that people are doing that sort of work, and they're building these agents, they're benchmarking it, but more importantly, they're kind of building this representation of a project space where they have issues and they have a way to sort of get an agent to modify things and improve things and see what those look like. So, even though we're kind of interested in what humans are doing in teams, this is, a way to sort of say, okay, this is what happens if you have some contribution scheme. Is this better or worse? What are the failure points? You can identify them with an agent like this because you don't need, you can run a lot of experiments on things, and it's really interesting. So, yeah, this is something that we'll be talking about more later. I'd like to see like some of the repositories and what we can do with this. The last thing I want to talk about today is this article by gael-varoquaux, and he's a French. He works on scikit-learn. He's based in France, and so this is where they talk about promoting open source from inria to probabl. And probabl is, I think, a startup. Inria, of course, is the French national.
Yeah, it's kind of a spin out from inria. Yeah.
Okay. Yeah. So this is open source efforts around scikit-learn, which of course is a machine learning sort of package. At Inria are spinning off a new enterprise, probabl, in charge of sustainable development of a data science commons. So they're actually working on building this data science commons. So basically what they're saying is funding scikit-learn is hard. So scikit-learn, of course, is this machine learning package. It's a central software component in today's machine learning landscape. It's open source and governed by a community, easy to install, and is well documented, and that's great. But you need people to maintain that. You need to have that community be active, and then, of course, motivated to do things to improve scikit-learn, to maintain it, to get it, into people's hands. It started many years ago as a project that we did on the side, and we're joined by many volunteers, which is the key to the success that we've seen. We soon decided to ensure that if scikit-learn was not only a volunteer-based effort, we'd have to sort of invest in it and make it more formal. Over more than a decade, I dedicated a lot of energy to this, using a variety of funding mechanisms. First grants, academic type grants, and then sponsoring and related contracts with various actors. And that's really, we have very limited options sometimes for funding these kind of activities. You have like grants, you have sponsorships. There's no real good infrastructure for funding these things, especially if they spin out of like the academic world, because there isn't like this profitable thing that you can sell necessarily. So it's hard to fund, and especially digital commons.
It gets at the open source sustainability, project in some ways, right?
Oh yeah,
And it was really interesting when I was spending a lot of time there in Paris in like 2017, 2018. The discussions that they had about just how they could compete in data science, ML, deep learning with the Americans, basically, with the deep pocketed Americans, and how important the
some of the kind of philosophies and objectives that scikit-learn took were really guided by that in terms of growth and sustainability.
Yeah, definitely. So they say that digital commons eliminate scarcity and exclusivity, and there's some footnotes here. Many commercial tools are sitting on top of open source software like scikit-learn. So this is something where you have commercial tools sitting on top of this tool that's a digital commons. The commercial tools don't always contribute very much to the commons, but they depend on it. So, there's this idea of tragedy of the commons where, people use the commons but don't contribute back to it and they collapse. And of course, there are other ideas about, how to maintain a commons in the face of, free riders and things like that. There's a whole literature in economics on this, but this is a problem. And, they're just finding a way to fund the commons. A lot of times governments will step in and give money, like the French government, to commons because it serves a purpose for the community. In the C. elegans community, we have tools like Wormbase, and they get funding, and they also get, funding just by virtue of being useful to the broader C. elegans community. So they get biomedical funding because the biomedical community is very dependent on sort of that C. elegans work. And so, yeah, definitely. Go ahead.
Well, I was just going to say also, software security, supply chain security, just in terms of, when you've only got one developer maintaining something, another developer comes along, says that they're going to help out, like in the case of, what was it, XY, that developer happens to be a Chinese agent and starts adding commits.
Right.
There's a, and as NumFocus points out on a regular basis, like the Python scientific software community is supported, is developed by and maintained by like 15 people or something like that.
Yeah.
It's really remarkable, but very, potentially very fragile.
Right.
Again.
Yeah, so this is definitely a problem. Some of the things, we, of course, as they say, the French government, in exchange for funding, they wanted a sustainability plan and some private investment to back it. This is not what he's good at because a lot of people in, open source, they don't have the, they need the domain expertise of people who are maybe working in government to really kind of meet the demands of government officials and take advantage of their funding and support. So this is where you get people like tech entrepreneurs involved, and so this basically just talks about a lot of the challenges here. One of the first things that Probabl, which is the spinoff, did was to submit a grant application to the Chan Zuckerberg Institute, which of course funds a lot of biomedical stuff, but also a lot of machine learning application stuff. They also funded things through NumFocus. So NumFocus helps organizations like this submit grants. And this is where they're basically trying to get grants through, mechanisms that you wouldn't normally go through. And then Probabl, of course, is the spinoff. So they started with a strong open source team. So they have 9 people working on open source. And so that's great to have a good starting point, to have a team dedicated to some of these things. They've also fostered an ecosystem, not just working on scikit-learn, but working on 8 libraries that they've identified that are important to scikit-learn, and working out some of the sort of the maintenance and sustainability of those. And then, making sure that those things are available to people. Our goal is to have a healthy open source ecosystem around data science. And then not only software, sustainability is only partially about software, of course, about the code. You need to do outreach and communication to not only programmers, but to decision makers. And that fills the gap between, say, like government funders or about private funders and your project. And so, they need to at probabl, we dedicated energy to be in the business meetings, to participate in the tech narrative, to teach how best to do data science with specific things like didactic videos, and having a mentoring program so that people are properly mentored. And this is a long-term investment, but it does give us like this space to say, okay, these are the things we can do to make this project successful in the long term. This is the sort of stuff we need to do to ensure success going forward and keeping that community robust.
I was just wondering, excuse me, I'm kind of wondering what prompted this to happen now, and like how much, I know how many like French, Paris-based researchers have been hired up recently by FAIR, whatever, Meta Research.
Yeah.
And Mistral, the big, there's a big effort, and that is probably sucking up a lot of talent to generate a French LLM company. And like how much of this is kind of a defensive maneuver, in terms of trying to keep people. Just curious, and like how much that's happening to us in San Francisco too. Just where it's just like, with the community biolab, we had people that are super talented, have things willing to contribute. We've totally lost them for like months and months as they work on trying to get a multi-million-dollar valuation for some sort of AI spinoff.
Yeah.
yeah, I'm sure it's happening everywhere. Yeah.
Oh yeah, and plus, if you have more and more users of the platform, like with the commercial users, you have certain expectations to keep the infrastructure in place, and so there is that need too. I know that like as sort of AI has become hot, especially in academia. Like I'm in a school where they've kind of shifted focus over the last 10 years greatly in what they do. And one of the things they do is to serve the students' interest in AI. So they're always trying to like find opportunities to bring that into the curriculum. And it's just because that's the hot thing. If there were like, if there are other parts of information science that were hot, they'd focus on those. But there's a need for, people want to learn about those things, so they devote resources to them. And sometimes, we're not as forward thinking about it as we'd like to be. So we're like, okay, what do the students need to know in 5 or 10 or 20 years? But also, what do they need to know like right now? Because what's out there? What are they hearing about? Is there a need for a formal curriculum so they can go out and be at the cutting edge of the field?
Yeah. I do. I mean, I just want to second what Jess said, which to come back to Jan LeCun's, larger meta brain model for AGI at some point.
Yeah, they're talking about things that we've been exploring, but like more from a theoretical perspective. So definitely, there's a need there. We should try to match it. Maybe, I don't know, because I mean, in the field of AI right now, there are a lot of like implementations, but there isn't a lot of like fitting those together in theoretical frameworks. It's definitely an area that needs more work. Or we can contribute to, I think, hopefully. Okay, so well, thank you for attending the meeting, and hopefully next week, we'll have some more project updates. Yeah. So thanks for attending. Have a good week. Bye.
Thank you.
Thank you. Take care. Bye.